This is the Professor, CBMD PhD, and today's Thursday, September 7th, 2023. It is 11:18 and 15 seconds, p.m. Eastern Standard Time, and today's research, Entropy. So let's hop to it here. Grasping Entropy, teachers and students investigate thermodynamics through a hands-on model. The model uses everyday materials like dice and buttons to effectively demonstrate the concept of entropy to students. Date September 6, 2023. Source: American Institute of Physics. And though a cornerstone of thermodynamics, entropy remains one of the most vexing concepts to teach budding physicists in the classroom. Physics teachers designed a handheld model to demonstrate the concept of entropy for students. Using everyday materials, the approach allows students to confront the topic with new intuition, one that takes specific aim at the confusion between entropy and disorder. It is a huge conceptual roadblock. The good news is that they found that it is something you can correct relatively easily early on. The bad news is that this misunderstanding gets taught so early on. While many classes opt for the imperfect, qualitative shorthand of calling entropy disorder, it is defined mathematically as a number of ways energy can be distributed in a system. Such a definition merely requires students to understand how particles store energy, formerly known as degrees of freedom. And to tackle the problem, scientists developed a model in which small objects, such as dice and buttons, are poured into a box, replicating a simple thermodynamic system. Some particles in the densely filled box are packed in place, meaning they have fewer degrees of freedom, leading to an overall low entropy system. As students shake the box, they introduce energy into the system, which loosens up locked-in particles. This increases the overall number of ways energy can be distributed within the box. You essentially zoom in on entropy, so students can say, "There is where I saw the entropy increase." As students shake further, the particles settle into a configuration that more evenly portions out to the energy among them. The catch: at this point of high entropy, the particles fall into an orderly alignment. Even though it looks more orientationally ordered, there is actually higher entropy. All the students who participated in the lesson were able to reason to the correct definition of entropy after the experiment. The scientific investigators and researchers plan to extend the reach of the model by starting a conversation about entropy with other educators and creating a broader activity guide for ways to use the kits for kindergarten through college. They hope this work inspires others to clarify the distinction in their classrooms, even if by do-it-yourself means. And this is the Professor of Space Technology, Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.